Hello, my students. Welcome to this lesson about arithmetic sequences. I hope you have your pen, paper, and calculator ready because you will be actively working with me as I interact with you, regarding arithmetic sequences. So we are definitely using the book, of course, Inquiry Approach to Mathematics. And today we are on page 44 to 46. Okay. So now, what are we given? Look at it. It's a sequence, 6, 13, and 20. Now, the first question is asking, is this an arithmetic sequence? All right? So remember, in inquiry, you look for keywords, you look for the meaning of what you have. You look at the connection between symbols. Okay, look at the question, is this an arithmetic sequence? So in your mind or in your brain, you want to, pull out the resources that has to do with arithmetic sequences. So how do you do that? By inspection, you can clearly see that this is indeed arithmetic because we are adding 7 each time, okay? But on paper, you also need to justify your answer by doing what? As you're thinking about arithmetic sequence, you know the property that goes with an arithmetic sequence of which is what? Yes, I'm hearing constant first difference. All right, that is what we need to do for this question. And it is a 1-mark question, so it's a straightforward question. We are just given 3 terms and it's an infinite sequence that is given. In other words, it is proceeding to infinity, and the last term is not indicated, as we can see. So let's start. We can, confidently say, yes, it is an arithmetic sequence, okay? And how can we prove that? We can see that from one term to the next, or between any 2 consecutive terms as they are given like this, we have a constant difference of what? 7, okay? So the justification becomes that there is a constant first difference of what? You can even specify it. D is equal to 7. And there we are. You are done like that. Okay. So B, read the question. Determine the formula for the nth term of the sequence. Again, you look at the question. Determine the formula. So that is what you do. That is the action word. You want to know what is expected in the question. You need to come up with a formula that is expressing the nth term of the sequence right here. Okay, you've identified that indeed it is arithmetic. So looking at the list of formulas, and of course you are given a formula sheet, you don't need to memorize these formulas, but you need to know which formula goes with what or which type of sequence. Okay, so the nth term for an arithmetic sequence is what? So in your mind, you're just thinking along those lines. You just pulled out the file for what? Arithmetic sequences. And you are just having that as a focal point. So what is the nth term? The nth term is the general formula of the sequence. It helps you to find any term or the position of a given value of the term. Okay, it works in both directions. So B, we are looking for the nth term, and we understand that for an arithmetic sequence, the nth term is expressed as the first term plus the nth term where we are minus 1 times D. Okay, D being our constant difference there. So now, how do we proceed? We understand that A is equal to what? The first term, and that is equal to 6 according to the given sequence right there. Okay, what is our value of D? Our D is this guy right there. It's 7. All right, so far I believe you're with me. We're then just doing what? Identification work, and thereafter substitution work, which will help us to write out our nth term. and ultimately, of course, answer the question. Okay, so we've identified what the question wants from us and then how to get there. So now we have Tn equal to what? 6 plus n minus 1 times 7. Okay, you can write it neatly like that with a a bracket as well. And we don't leave the answer like that. We write it in standard form, in linear form. In other words, we want to distribute. We have 6 plus 7n minus 7. Okay, and therefore we have Tn is equal to, you write your term with n or the variable first, and it's 6 minus 7, which is what? Minus 1. And that is what we have. So of course you can write minus 1 plus 7n, but this is really connected to the linear function. And that is the connection that you as a student, I encourage you to see from here, because from here, if you look, it's y equal to mx plus c type of equation. Okay, so remember, another word for an arithmetic sequence is a linear sequence. Okay, where this 7 represents the gradient in terms of the language under functions. And because a straight line or a linear function has a constant gradient, that is where the word constant comes from. So this one will be an increasing function since the gradient is positive 7. What is the y-intercept? The y-intercept is negative 7. So here we're just dealing with what? Sequences. Here it is functions. But the concept mathematically is the same. Okay, so I believe you're with me there and you are following. All right. Good. So we have C now. We have C. Calculate the 90th term. Okay. So what is the action word? Calculate is what you need to do. But what must you calculate? The 90th term. Okay. Inquiry. What? What does the 90th term mean? Does it mean the position of the term or the value of the term? So you gotta be clear about that. So the sequence, or actually the question, is telling you calculate the 90th term. So this is the first term, this is the second term, this is the third term. So somewhere very far from the third term, of course, we have T90 right here, and we are looking for the value of T90, okay, 90th term. But you can see that we have a tool to help us do that, because the general formula allows us to get the value of any position of any term in the sequence. All right, so let's start. C, we have T90 will be equal to, in other words, in place of n, we are now substituting 90. So we have 7 times 90 minus 1. We have 7 times 90 minus 1. Now run through your multiples or do this on your calculator. What is 90 times 7 or 7 times 90? That is 630. And then you are minusing 1. Okay. And then this will be 629. And there we are with the third question of the 4 sub-questions under question 1. Okay, the last question. The last question. Determine which term of the sequence is equal to 97. Okay, so here we want to know which term of the sequence is equal to 97. Now, reasoning from what we have just found here, we know that this value here is 629. Okay, and we want the following. We are at D now. Okay, D says determine which term of the sequence is equal to is equal to 97. Okay, So in other words, are you looking for the value of the term or the position that corresponds to 97? You are looking for the position, you see, because the question is clear there. You highlight the word which term. Okay, so you are having a value of 97, and because this is an increasing sequence, 97 will definitely be less than 629, or is definitely less than 629. So we put 97 somewhere there. Okay, we don't know the position of this 97. That is what the question is asking you. So inquiry means now you want to see how numbers fit in and in relation to the others, and use your tool to do what? Get the answer to the given value of the term. So now what do we have? Tn is equal to 97. We don't know the n or the position of this number here or this value 97. So we understand that we have Tn is equal to 7n minus 1. So our Tn, or the value of the term, is 97, which is equal to what? 7n minus 1. Okay, so then you take this and you, of course, transpose the minus 1. It's 97 plus 1, which is equal to 7n. Okay, so now how do we work this out? You now have 98 is equal to 7n, and then dividing both sides by 7. Dividing both sides by 7 gives us that our n is equal to what? 14. Our n is equal to 14. That means that in position 14 in the sequence, the value of that position there, or the value that is corresponding to that position, is equal to 97. Just like when you come to your equation of the linear function, you have input and output values here. You see input and output values. Okay, so your inputs are your n values, and then your outputs are your Tn values. Okay, then that is how you see that relationship, that indeed this is a function, but we are investigating it in terms of sequences, numerical, patterns or number patterns. Okay, so guys, this is it for this lesson. What I want to end off by doing is to help you see the mark allocation. All right, let's start with D. Since we ended with D, this is 2 marks. So how will you get the marks? Of course, you get 1 mark for your answer, but how do you get the other mark? Correct substitution of 97. Okay. C, calculate the 90th term. This was 1 mark. The substitution there takes place, and then you get your answer 629. And then B, how many marks is this one? 2 marks. So you get a mark for substitution of both A and your D there, and then you get a mark for your simplified expression for the Tn. And of course, the first question was about justifying that indeed it is an arithmetic sequence, and you get 1 mark for that, pointing out that there is a constant first difference. So guys, I believe you've enjoyed the lesson. I'm gonna end it here. Thank you for tuning in. I'll see you next time. Sharp, sharp.